Hello everybody, this video accompanies notebook 1 in the series of videos Exploratory Computing with Python. My name is Mark Bakker and I work at the Delft University of Technology. Today we will learn how to start the Jupyter Notebook, learn some Python basics and how to plot a function. But of course first you have to install Python. The easiest thing to do is to install a Python distribution. There are many available and what I'm using here is Anaconda. Go to the Anaconda website, download the Python distribution for Python 3, install it on your computer, and then depending on what the system you have to find where it is installed. On Windows, you go to the Start button, find Anaconda 3, and start a Jupyter Notebook. On a Mac, you have to search around a little bit where it has been installed. There's an Anaconda 3 directory somewhere. Find the Jupyter Notebook icon or the Anaconda Navigator icon and click on that. Once you click on that, Anaconda opens your default web browser and what you get to see is the Jupyter dashboard. And this is the dashboard on my machine, where here you see a bunch of directories that happen to be in the directory where my system starts up. Yours will look different, of course. On Windows, it probably starts up in your Documents folder. On a Mac, it starts up in your Home folder. If you want to open an existing notebook, click on one of the notebooks in your folder. I don't have any here, but I can go to a lower directory and you can click on one of the notebooks that start with PYNB for IPython notebook. But what we're going to do today is we start a new notebook. We go to New and start a new notebook. You probably don't have more options here. I can actually start a notebook in Python 2 or in Python 3, but you may only have Python 3 installed, and really that's all you need and should have. So you click on Python 3, it opens up a new notebook, and it looks like this. Where it starts, the very first box here is called a code cell, and there you can type Python code. And a very easy thing to do is first use Python as a calculator. We can type here 2 plus 3, and then if you hit Shift Enter, so I pushing on the Shift key and then hit Enter, it executes that command and it adds to the 3 and it prints to the screen what the answer is, and it's 5. Now I added a little space around this plus sign. I could have just type 2 plus 3, and if I type Shift Enter again, it will still execute that. But it's much easier to read if you add the spaces, and quite frankly, in Python, it's considered good style if you add the space just because it makes it easy to read. So try to add the spaces around these symbols. But of course, we don't want to just use it as a calculator. We want to start using variables. So let's do that in the next code cell. We define a variable called a and we give it the value 2. We define a variable called b and we give it the value 3. And we do a plus b. And by golly, it is still 5. In fact, we could have just stored a plus b in a new variable. Let's call it c. And if I hit now Shift Enter, nothing happens. Why not? Well, because there's nothing to enter to the screen. What's it supposed to do? If I want to know what the value of c is, then I type print, I open a parenthesis, and I type here what I want to see, and I want to see the variable c. And it is equal to 5. I can make that print statement much nicer. I can say, the value of c is, so the text here that I printed here is between quotes, so that Python knows it's text. You can either use single quotes or double quotes as long as you start and end with the same one. And then if you want to print the next thing, you have to enter a comma and then what else you want to print. So I can enter this and it nicely prints that to the screen. Or you can say the values of A, B, and C are, and then you print here A, B, C, again, all separated by commas, and it will nicely print that A is equal to 2, B is 3, and C is equal to 5. Once you've defined a variable, it is available in all the code cells. So I can also print here, print A and B, nicely get the values, but even in the cell above it, if I print here A and B, it also knows it. Why does it know? Well, because this cell was executed after this cell where I defined A, B, and C. And you can see in which order cells are executed by the number in front of it. See, this cell was executed as the 8th cell that I executed. This one was the 9th. This one is the 10th. If I execute this one again, it will be the 11th time I execute a code cell. And that's the order in which things go. Of course, by the time you're done, you want to make sure you can run your notebook by starting with the code cell at the top and run them all in sequence. And to see if that works, you can go to cell and just say run all. And then it will start at the top. This is the 12th one, the 13th one, and the 14th one. Or better yet, to make sure it actually runs from the start without having done anything yet, you can go to kernel, restart and run all. It will restart the system, or at least it will restart Python. It will even ask you, you really want to restart? Yes, restart and run all cells. And you will see we get an error because at the first code cell it says print A and B, and it says name A is not defined. Of course, if you start a fresh Python session and this is the very first cell you run, it doesn't know what A is. So let's get rid of this statement. We cannot give that statement unless we run this cell, but we want to make sure we can run them in order. So we say kernel, restart and run all. And now things should run fine. There we go. All right, we go up to the next thing. We want to try to calculate a parabola, values of a parabola, and even make a plot of a parabola. So let's do that. We type y is equal to x minus 1, note the spaces that I add, times x plus 1. So that's a parabola. That is 0 at x is equal to 1 at 0, and 0 at x is equal to minus 1. And I do shift enter. And I again get an error. Let's see what it says now. Again, if you get an error, you always start reading at the bottom, and it says here, name x is not defined. Ah, that makes sense, of course. If I would have said here, x is equal to 5, then it can calculate, all right, it stores the value of 5 in the variable x, and then it calculates y as x minus 1 times x plus 1. And then if I print y, you see we get the value of 24, and that is indeed the correct value. Now, if I want to plot a parabola, I have to calculate y for a bunch of values of x. And how do I make a bunch of values of x? Well, a bunch of values in programming is called an array. And to make an array of x, we have to use a package. Arrays are not part of standard Python, but there are a lot of packages. They're also called libraries in other languages or toolboxes. And those packages give additional functionality. And the package we're going to use, in fact we'll use it in any of those notebooks you'll see in these kind of videos, is called numpy. And to be able to use a package, you have to import it. So I type import numpy. And I hit shift enter. Now I can use any function in numpy, and it has a lot of mathematical functions and a lot of array functions that I want. For example, I can say x is equal to numpy.linspace. I open the parenthesis, and then I can run the linspace command that gives you a bunch of values between a min, a max, and then a number of values. But to get help on this function, this linspace function, once I've opened the parenthesis, I can hit shift tab. So I'm entering shift tab now on my keyboard. And then what you get is you get help. It tells you what you should enter. And what you should enter is a start value, a stop value, and a number of values you want to see. For the start value and the stop value, you have to give a value, but for the number of values, there's actually a default 50. So if you don't specify that value, it will use the default value you see here. And there are some other options, but we are not going to use those now. So let's say I want to have x go from -4 to +4, and I want to have 10 values. And let's print x. There you go. There's 10 values from -4 to +4, evenly spaced. Once I have those 10x values, I can calculate y for those values of x. So y was x minus 1 times x plus 1, and I can print y. Oh, print y. Get an error message with syntax error, it says. Missing parentheses in call to print. Oh, that's right. Print is a function, like you see here in the other times I've used it. So it needs parentheses around that. So I need to say print, open parenthesis, y, close parenthesis. And then hit shift enter. And I get the values of y for those values of x. Next, I want to plot the parabola. Make a graph of x versus y. To do that, we have to again use a package, and the package is called matplotlib. It's the main plotting package used in Python. So we import that, and matplotlib has a lot of functionality. We only want the plotting part, and the statement for that is import matplotlib lib.py plot. Now, that means that from now on I can use any function, for example the plotting function, by typing matplotlib.py plot, the plotting function, and then say x versus y, and I will get a nice plot. But before I do that, I have to give one more statement. And the additional statement is that I want to tell the Jupyter Notebook that if I make a plot, I want to see it in the Jupyter Notebook. And for that there is a magic command, and they truly are called magic commands. They start with a percentage sign. So it's percentage matplotlib inline. And we're going to use that in every notebook we'll be using in these videos. So we enter this, shift enter, don't forget to execute it. And then we enter, we do shift enter on this, so we run this line and we get our nice graph. Now what I don't like is that if I want to run any of these numpy functions, I have to type numpy dot. Well, that's maybe acceptable. But if I want to use any of those plotting functions, I have to type matplotlib.py plot dot and then the function name. That's too much typing. Luckily in Python you can rename everything. So we're going to do that, and there's a standard for that. The standard is to say that numpy is going to be abbreviated to np. So I'm going to type import numpy as np, which means that, and I hit shift enter, that I can, instead of typing numpy.function name, I can do np.function name. And the matplotlib.py plot package is often called plt. That's the standard we'll be using. So now I can, instead of having to type all this, I can type plt.plot and then x versus y. I like this figure, but I don't like it a whole lot yet because it's too raggedy, right? It's not a nice smooth curve. It's too angular, maybe is the better word. So how do I make it better? Well, remember there's only 10 points along this line. Let's make it 100. So I go back here. I say x is a linear spacing from -4 to +4 with 100 points. I run that. See, if I print y, I get 100 points. So let's get rid of that print statement because that's a lot of points to show to the screen. I don't have to run this again. We've already done that. That package has already been imported. And then I do plt.plotxy and I run 100 points. Much nicer. Let's add some labels to that. There's all kinds of functions in the matplotlib package, and we'll learn very many of those statements in upcoming notebooks. But there's one called xlabel. It's also a function, and if you now type between the parentheses the string you want to see along the x-axis, so we open a quote and we type x-axis. That's a little bit boring name. And then we, of course, will want to add something to the y-axis. It's called y-label. And we add parabola. Then you see nicely there's a parabola statement added to the vertical axis and an x-axis statement added to the horizontal axis. Let's do a few more things. Plotting function has a lot of capabilities. Right? You can type plt.plot and an open parenthesis. And remember, if you hit shift tab, it will open up the help. And it doesn't look like the help as much, but if you click the plus sign here, this will open up in a scrollable box where you can see all kinds of statements that you can run. Then if you hit the X, it's gone. Another way to get help is to type plt.plot, if that's the function you want to have help on, and then type one question mark. Again, hit shift enter, and you get nice, in the bottom part, you get also a scrollable window that remains open also when you are typing stuff here. Now, one of the things that you can see here is that you can define a color by typing one letter. There's many different ways of defining color. There's other ones listed here, but one of the ways is to just give one letter names: blue, B for blue, G for green, R for red. So we can go back. Let's close this up. We can make the line red, for example. And finally, we can add a legend. We can say plt.legend. And the legend has to be between square brackets and then the name. And the name in this case is first line. How about that? And it adds a first line legend. And in fact, you can even tell it, figure out the best location you can find so that it doesn't overlap with any of the line we've shown, and it decides the bottom left hand corner might be the best spot. There's other ways to define where to put it, lower left, upper right, whatever you can think of. That's all I have for you today. I hope to see you next time.